or we reflect about y-axis depends. If our function become minus fx or x in our function become negative, become minus, we reflect about y-axis. If our function become minus, we reflect about x-axis. Then we may have also compress or stretch. And when we talk about compress or stretch, either it's vertical or horizontal. Either horizontal or vertical compress stretch. Vertical compress stretch happen when our function x, our function, we multiply with c. We get the vertical compress or stretch. How do we know whether it's compress or stretch? Look at the value of c. If c is greater than 1, stretch. If c is located between 0 and 1, compress. Or if our x is multiplied by c, not our function multiplied by c, our x we multiply by c, so it's horizontal, either compress or stretch. How do we know whether compress or stretch? If c here is a number greater than 1, compress. If c is located between 0 and 1, stretch. And type of number 4 of transformation is a type of vertical shift. When we talk about vertical shift, it's either shifting it up or shifting it down. Shift up or shift down. Either go up or go down. When is going to be up? When our function we adding with c. When our function we minus with c is going to be down. Questions regarding shifting?
Sir.
Yes.
Sorry, I cannot see your screen clearly. Your screen not clear.
Can you see it?
No, your screen pecah-pecah.
Blur, sir, blur.
Blank.
Blur?
Blur.
Because I use pencils here, right? So remember this. Remember always, horizontal shift happen when x plus c or when x minus c. Reflection happen when minus of fx or minus of our x. Compress or stretch happen when, but when we talk about compress stretch, we have to verify either it is vertical or horizontal. If it is vertical, vertical happen when c multiplied by our function. Horizontal happen when our function will multiply with c. When x will multiply with c, not our function multiplied by c. And also the last one, we have vertical shift. When we talk about vertical shift, it can be either shift up or shift down. Shift up or shift down. And all those we have to do one by one. We have to do flow using the flow, which means that we have to start with horizontal shift and then go to reflect, then go to compress stretch, and then go to vertical shift. We cannot go straight. Let's say I want to do number 2 first, and then number 3, and then go to number 1. No, cannot. You have to follow. Go one by one. In some of the transformations process, not necessarily that involve all of them. Some of transformation process only involve of 3. Maybe we don't have horizontal shift, or maybe we don't have reflections, or maybe we don't have compressed stretch, or maybe we don't have vertical shift. So the importance when we look at what functions we want to sketch for transformation, so we have to determine what is our basic function that we want to start with. For example, sketch the functions of fx two minus 1/2 x minus 1, absolute value, by using techniques of transformation. Show at least two points at every stage. Hence, state the domain and range of fx of the function that we sketch. State what is the domain and what is the range. We will know domain and range. When we sketch the function. And now this function we want to sketch. So what is the basic functions that we have to start with? We want to start with what is the basic function that we want to start with. If you look at this function that we want to sketch, it will involve one transformation, two transformation, three transformations, four transformations, four steps of transformations. And when we look at this function, which function we want to do as a basic function, or the one that we want to start with before we go further. Then when we look at this function that we want to sketch, it's clear that the function we want to start, and we need to start, must be absolute value function, because we have absolute value here. So the one that we need to start is absolute value function. What is the shape of absolute value function? Because we want to start with absolute value function. What is the shape of absolute value function? What is the shape of absolute value function?
Reflection.
Yes.
Reflection.
Huh? Absolute value function. What is the shape? Shape. Everyone just want to know the shape.
Straight line, sir.
Straight line. Straight line is linear. Straight line is linear function. Absolute value function.
V.
Just told you last week. V. And what's the point here? Because we need to show at least 2 points. What is the point here? What's the point? The points here. What is the point there?
-1 je.
The point is -1.
1, sir.
The point is 1. What does it mean by point? What does it mean by point? If we go further, because the way you just show that you don't know what does it mean by the point. You say point is -1, point is 1. Point is point. I don't know whether you study during SPM or not. Point is this. X and Y. Wherever we have X, we have Y. So how can The point is minus 1. What? Is that x or y? Okay, what is the point here? What is the point here?
0,
0,
0.
0.
0, 0. And because we need 2 points, we can have another points. What are another points? What are the points? From this graph, for this graph, what is another point?
One, sir.
1, 1. And the point 1, 1. What is this? And this function is function of absolute value of x. We say this is a basic function that we don't do any transformation yet. Why we choose this as a basic function? Why not another function? Why? 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 Why we have this? Why we make this as our original or basic function? Why we don't choose another function as our basic function?
Modulus, sir.
Because we want to sketch this. We want to sketch this. The value here, 2. We want to sketch this. Therefore, whatever we sketch, we're going to have modulus. So we need to start with the modulus or absolute value function. We cannot start with another function because it will involve our modulus. Now we start of our transformation. Right. So what's we get? Is the horizontal shift involved? Is the horizontal shift involved? Because we go one by one, we have to go through this. We cannot go straight to go to number 1. No, we have to start with number 1. Horizontal shift. Is that involved horizontal shift or not? Involved or not?
Yes.
Yes, it's involved. You can see that. Yeah. So what can we say? What can we say? Horizontal shift involved shift to where? Shift to where?
-1.
To right.
She only do either right or left, not shift to -1. Shift to right or left?
Right.
Right. By 1. 1 unit. Meaning that our new graph will go to here, right? We shift. Shift to the right now. We shift to the right. This one, we shift. Like this. You can see, the meaning of shifting. It's like this. Let's say pen. Shift to the right. Shift to the left. Shift. See like this. Shift to the right. Shift. Shift to the left. Shift. When we shift to the right, we calculate this. We go step by step, each step by each step. Therefore, x, y, x and y here, right? Point 0, 0, we'll go to which point here? Now, because we shift. What's with the new points?
1 0.
1, 0.
1 0.
Points 1, 1 will go to what points?
2 1.
2,
2
1.
1.
2, 1. And what is the new function now? Our new function is square absolute value of x minus 1. One transformation involved, shifting. We go to the next one. Right. Remember that reflections and compressions can be interchanged. Interchange here meaning that we can do compression first and then reflection. Or we do reflection first and then compression. Now, what do we want to do next? What do we want to do next? We're in this stage now. Our function now become this. This is our stage now. What do we want to do next? What we need to do next?
One over two.
So what happened?
The value x divided by 2.
If you x divided by 2, no. X not divided by 2. When you see 1 over 2 is here, right? Correct, 1 over 2 here, 1 over 2. What happened? You see, we go to which one?
Compress or stretch.
Compress or stretch. So if 1 over 2 we multiply by our function, right? It becomes here, right? vertical. Understand? You see? If 1 over 2 here, C is 1 over 2, you multiply by our function. 1 over 2, you multiply by our function. It's going to be this, right? Can you see?
Yes.
Yes.
Therefore, what is stretch or compress? Stretch or compress?
Compress.
Compress. Because why compress? Because our C now is 1 over 2. Look at it here. So when compress, our function become compress vertically, compress. So our function is 1 over 2 x minus 1. And 0.010, sorry. Let's go to here. Ah. 0.10 will go to which point? 0.10 will go to what point?
10.
10 remain. Why? Because now when we talk about vertically compressed, it's involved of only y. Every y coordinate must be multiplied by 1 over 2. Because 1 over 2. And because y is 0, when you multiply by 1 over 2, we still have 0. That's why 1, 0. And 0.21 will go to which point? 0.21, which go to which point?
2, 1 over 2.
2, 1 over 2. 2, 1 over 2. Why 2, 1 over 2? Since every y coordinate we multiply by 1 over 2. So 1 multiplied by 1 over 2, we got 1 over 2. So this is the shape of the graph and this is the function. This is our latest function. Our function become this now. Is it finished? Is it already finished?
Not yet.
Not yet. Because we still have what?
2.
Before 2?
Negative.
Yes. Before 2? Yes, 2, 1, before 2. We have what we have?
Negative.
Negative. So if negative, what happened?
Reflect.
Reflect about what? About x or y?
X.
About x. Why about x? Yes, reflect about x. But why about x? Reflect about x exists, yes. But why about x exists, not about y exists? Why? Why about x exists? Yes, correct. About x x exists, but why?
Because negative multiply by function.
Because negative we multiply by our function. Our function now is 1/2 absolute value of x minus 1. When negative we multiply by this, it's reflect about x exists. Therefore, our function becomes like this. X, y, reflection about x exists. We say that. 0.10 will go to which point? Because we want to move to know the movement of the points. 0.10 will go to the which point?
10.
Stay 10. Points to 1/2 will go to what point?
Negative 1/2.
To negative 1/2. And what is our new function now? Our new function is negative 1/2 absolute value of x minus 2, x minus 1. So up till here, we have one more to go, which is to be plus 2. Plus 2 meaning that what?
Vertical shift.
Vertical shift. We go to the number 4. Right, we go step by step, right? We go here, the first one, and then the second one, or the second and third can be interchanged. In this case, we do the third one first, and the second one first, and the second one. We in the stage of second one. We put negative, and we go to the fourth. We shift. Either shift it up or shift it down.
Up, sir.
Up. Shift up. Okay. Shift up. How many units?
2.
2 units. Therefore, our graph will become up. Right. Up. For 2 units, for how many units? For how many units? Big points. 0.10 will go to the points.
1, 2.
Huh?
1, 2.
0 will be 2.
Yeah. 0.10, sorry. No, let's shoot like this, sorry. Let's shoot it, we go up. Okay. Now we go up. This is X, this is Y. We shift up the units. 0.10 will go to the points.
1, 2.
1, 2. Because we shift it up. Points 2, negative 1/2 will go to the points. Points what? Points 2, negative 1/2 will go to the points 2.
1/2.
negative 1.
3/2.
3/2. Because we go up to units. We go up to units. And our function now, the last function, is function 2 minus 1/2 x minus 1. Right. Which is same. It is this. This we want to sketch. And we got this. This is the shape of the last function. And the point. We want to show, we want to look the movement, we want to look at the movement of the points. Start with 0, 0. Let's say this point. Start with 0, 0. We'll go to 1, 0. Still 1, 0. Still 1, 0. And then go to 1, 2. This point start with 1, 1. Go to 2, 1. 2.5. 2 minus and a half. 2, 3 and 2. 3 over 2. Now, the shape, we can say same. Only the difference between them is points. And that's why important to show at least 2 points at every stage. We have family stage 1, 2, 3, 4 stages. And in every stage, remember the 3 things you have to remember. You have to make sure you have to write the function. The function will be different. From absolute value of x become absolute value of x minus 1, and then go to this function, the last one, this function. 1. Another one we have to remember of the points. See, these 2 points, these 2 points, these 2 points, these 2 points. And the third one you have to remember what involved, the kind of transformation involved. From one step to one step, this transformation. From this step to this step, this transformation. So from this step to this step, you can see that it's compressed, right? Compress vertically. Then reflect, then shift. Those 3 things, the functions, points, and the process. So these examples of transformations which involve all this. Number 1, number 2, number 3, number 4. We have all of them. Some transformations, no. We only have maybe 3 of them. 1 not involved. But this transformation involve of all of them. Questions? Yes. Put in the group.
Yeah, everyone's the same, sir.
Okay. Okay. So break for a while, come back at 11 o'clock.
concern, but you walk by like you never heard. You could bring down my level of concern. Just need you to tell me we're alright, tell me we're okay. Panic on the brain, Michael's gone insane. Julie starts to make me nervous. I don't really care what they would say. I'm asking you to stay. My bunker underneath the surface. Wondering, would you be my little quarantine? Or is this the way it ends? 'Cause I told you my level of concern, but you walk by like you never heard. And you could bring down my level of concern. Just need you to tell me we're alright, tell me we're okay. Yeah, tell me we're alright, tell me we're okay. Yeah, tell me we're alright, tell me we're okay. Bring down my level of concern. Just need you to tell me we're alright, tell me we're okay. Yeah. 'Cause I told you my level of concern, but you walk by like you never heard. You could bring down my level of concern. Just need you to tell me we're alright, tell me we're okay. I need you. I need you to tell me we're alright, tell me we're okay. Need you to tell me we're alright, tell me we're okay. Need you now, I need you now. 'Cause I told you my level of concern, but you walk by like you never heard. And you could bring down my level of concern. Just need you to tell me we're alright, tell me we're okay. Yeah, tell me we're alright, tell me
Right.
we're okay. Yeah, tell me
Welcome back.
tell me we're okay. You could bring down my level of concern. Just need you to tell me we're alright.
Right. Ready for to continue?
Yes, sir.
Okay. So this is the last function that we have. Then that state the domain and range. What is the domain of this function? Domain and range. We go back to the domain and range. What is the domain of this is the last function? And then we state the domain of this function. What is domain?
Negative infinity to infinity.
Negative infinity to infinity. Because when you come from domain, we look at the x-axis. It's come from left, from negative infinity, and it will not stop until infinity. Range.
Negative infinity to 2.
Negative infinity until 2. Range negative infinity and stop at 2. We refer to y-axis. Right. This function. Let's say when we want to sketch another function. We want to sketch the function fx equal to minus square root of x minus 3 plus 1. We sketch by techniques of transformation, show at least 2 points at every stage. Hence, we state what is the domain and range for that function that we want to sketch, and definitely no more this function new function. Function which we want to sketch is function of minus x minus square root of x minus 3 plus 1. Minus square root of x minus 3 plus 1. Okay, so when we see the functions, which function we need to start with?
Square root x.
Square root function. So this is our basic function, square root function, and the shape of the square root function. The function, basic function, square root of x, and 2 points, we
Tak
choose
tahu lah. Tapi, ya Allah.
points 0, 0, or whatever points you want to like, because I choose 0, 0 because easy, right? Because easy to see the movement of that points. And the points we choose, what are the points we choose?
To shifting ke sir?
Huh?
The point to shifting ke?
No, the point of this function. What?
Oh, yeah.
1, 1.
1, 1. Not shifting yet, right? Point 1, 1. Then we're going to see these 2 points will end up where after the process of transformation. Okay. The first one, we go to the first one, horizontal shift. Is there horizontal shift happen here?
Yes.
Yes.
Is that shift right or shift left?
Right.
Right. Shift right for how many?
3.
3. Which means that we shift to the right 3. So instead of 0, 1, 2, 3. So this is the function of square root of x minus 3, and points of 0, 1 will go to the points of 3, 0. I see the movement here. And points of 1, 1 will go to the points of
4, 1.
4, 1. Shift right 3 units. Shifting to the right 3 units. Next, okay, after we finish the first one, next we go to the reflections. Or we go to compressions or stretch. It does not matter because it can be interchanged. Let's say we go to the reflections. Is that reflections happen here or not?
Yes.
Yes. Is that reflect about x-axis or y-axis?
X.
X-axis. Because minus of our function. So we have new function. When we reflect about x-axis, a new function we have. This is xy. So x, y. And point 30 will go to which point here?
30.
Remain at 30. And point 41 will go to the points?
Negative.
Huh?
4 negative 1.
Negative 1.
4 minus 1. And what is the function? What is the function? What is the new function now? Name?
-3.
Negative square root
Square root.
of x minus 3. So, finish of number 2. We go to number 3. Is that compress or stretch involved here? When you look at the function that we want to sketch, is that compress or stretch can involve here?
No.
We go to number 4. Is that horizontal shifting vertically involved here?
Yes.
Yes. Is that shift
Yeah.
up or shift down?
Down. Up.
Up.
Shift up.
Up, right? Up. Plus up. So, shift up. How many units? 1 unit. So, our graph will become like this. We up 1 unit. So, points of 30 will go to the points of 3, 1. And points 4 minus 1 will go to the points
40.
40. 40, this point. Right. So this is last. You get it? And the last function here is the function of minus square root of x minus 3 plus 1. You get it? Minus square root of x minus 3 plus 1. So this is the function that we want to sketch. And we see the movement of these 2 points, 0, 0, and 1, 1. At the end, these 2 points become 3, 1. Nearly same. Or we can say almost same. What makes it different? Points. Points make it different. And when we talk about points, it's supposed to be x and y. Not only one. I'm not say when I ask what is the point here? 1 or minus 1. No. Because must have a pair. X and Y. So points 3, 1, 4, 0. All the process of transformations right here, only 3, because the process of transformations only involved of 3 processes, unlike the previous one that involves of the 4 processes. Questions? Then we state the domain. What is the domain? What is the domain of this function?
3 until infinity.
3 0.
Until infinity.
3 infinity, sorry.
Range. Range.
Negative infinity 0.
Negative infinity 0. Why negative infinity until 0? Up until 0? Why? Not stop at 0. So negative infinity
Until 1.
until 1, you see. Until 1. Not stop at here. Go until 1. So negative infinity until 1. That's the range of this function. Let's say that the function new function minus x over 2 plus 4 power of 3 minus 2. A new function. Minus x over 2 plus 4 power of 3 minus 2. So when we look at the function that we want to sketch, this, what's supposed to be our basic functions?
Basic function ni X.
Huh? Our basic function, which one we choose to be our basic function? Cubic function. So This is cubic function, the shape of the cubic function. And we choose with 2 points, let's say points 0, 0 here, and one more points. Let's say points 1, 1. Let's say, or we can choose whatever points that we want. Next, we go one by one, the process of transformation. We have to go one by one. We go to number 1. Is that we have horizontal shift. Is that we have horizontal shift. Let me go from here, go down. The first one we have is that we have horizontal shift.
Yes. Yes.
So is that shift right or shift left?
Shift left.
Shift left. Therefore, must be shift left. How many units? How many
4.
units? 4 units.
4.
So the graph will become shift to the left. So 4 units. Therefore, points 0, 0 will go to the points. Will go to the points which one?
Negative 4, 0.
Minus 4, 0. And point 1, 1 will go to the points.
Negative 1, 1.
Negative 3, 1.
Minus 3, 1.
3, 1.
Because shifting to the left, shift is just like this one we shift to the left. And this is our new function, x plus 4 cube. Right. And new functions exist after this with the shifting to the left. You get it? Any question? Any question?
No, sir.
Okay. Then we go to the next one. Either reflect or compress stretch first, doesn't matter. Let's say. Let's say we do number 3 because we look here, right? We do number 3 first. Is that we have compress stretch?
Yes.
Yes. About vertically or horizontally?
Horizontal.
Horizontally. Horizontal happen where? When C multiplied by fx. Yes, C multiplied by x. So x now multiplied by what?
1/2.
1/2. So every when we talk about horizontal, it's going to be the movement left, right. So it involves only x coordinates. When we talk about left, right. X coordinates. So x coordinates must be what? multiply by 2. When we say that stretch, right? Stretch, horizontal stretch. Now we talk about the stretch, right? X coordinate must be multiplied by 2. So stretch, right? Horizontally stretch. So every x coordinate must be multiplied by 2. Points minus 3, 0 will become points of what? Points minus 4, 0, right? Minus 4, 0. The original, this point is minus 4, 0. We'll come to the points of what here? Because horizontally stretched, when horizontally stretched, every x coordinate must be multiplied by 2. Why multiply by 2? Because it's 1 over 2.
Minus 8, 0.
Minus 8, 0. Minus 8, 0. These the points will go. And points minus 3, 1 will go to the points of
Minus 6, 0.
minus 6, 0. Minus 6, 1. Sorry, not 0, 1. Because only x coordinate change. Minus 6, 1. X, y. And new function here, fx is x over 2 plus 4 cube. Any question? These 2 points change, you see. Point, we want to know point 0, 0 and then go to minus 4, 0 and then go to minus 8, 0 because of the process of transformations here. And then now because we go straight to number 2, 3, now we go to number 2, right? Because we have to follow the flow. Number 2 is about what? It's about what?
Reflection.
Reflection. Is that we have reflections here?
Yes, sir.
Yes. And reflections about what? X exists or Y exists?
X
X
exists.
exists.
X exists. Therefore, this will reflect about X exists. This is X exists. So we can say here that reflection about X exists. So we reflect become like this. Sorry. Because we reflect. we reflect, and this one reflect, and go. We reflect. And what is the point here? Pi minus 8 and 0 will go to which point?
Negative 8, 0.
Minus 8. Remain. Point here, minus 6, 1 will go to which point?
Negative 1.
Huh? Will go to which point? The original is minus 6, 1.
Minus 6 minus 1.
Minus 6 minus 1, you mean here? No, we want to know these points will go to which points of minus 6, minus 1.
Minus 1.
Okay. And what is the function now? The name of the new function? Fx is minus x over 2 plus 4 cube. That is the name of the function, current function. Okay. And then we go to the next one. We want to finish, go to the number 4. Vertical shift. Is that we have vertical shift?
Yes.
Yes.
Shift down.
Shift down or shift up? Shift down. Shift down, how many units?
2.
2 units. Vertical, shift down 2 units. So shift it down, go down. So minus 8, 0 will go to the points of
minus 8 minus 2.
Minus 8 minus 2. Minus 8 minus 2. And the point here is minus 8 minus 2. And points of minus 6 minus 1 will go to the points of
minus 6 minus 3.
Minus 6 minus 3. X, Y, and the function, the name of this function, minus x over 2 plus 4 cube plus 2, minus 2, minus 2, the one that we want to sketch. Hey. Any question? That's we say that sketching the graph by techniques of transformations. When we talk about techniques of transformation, you have to show stage by stage. Even though you can draw straight this graph, you can get straight. But when we say sketching using techniques of transformations, you have to show one by one. You have to show one by one. Questions. Then we have to determine the domain and the range of our function. What is the domain? What is the domain of our function? What is the domain of our function?
Negative infinity to infinity.
Negative infinity to infinity, because don't know come from and where is stop. Range.
Negative infinity to infinity.
Same. Negative infinity to infinity as well. Range, because we don't know where it come from and we don't know where it will stop. So negative infinity to infinity as well. Let's say another function one over minus 2 over 3x minus 3. sketch that by using techniques of transformations. Remember that when we sketch, you are using technique of transformations. We have to show that every step we have to show the function, what the function we get. Every step also we have to show points, where the movement of the points. And also from step to step, we have to show what happened of transformation, which transformation of this kind happened from that step to that step. And then after we get the function, the last function, we determine domain and range of that function. Right. When we look at the function that we want to sketch is 1 over minus 2 over 3 over 3x minus 3. So what is the basic functions in fact? What is the basic function that we need to start with?
Sir,
Yes.
is it a reciprocal function?
Yes, reciprocal function. Reciprocal function. This is reciprocal function, the one that we have to start with. Or we can say the basic graph. The points, choose points 1, 1, and points minus 1, minus 1. Next, Remember that for the case of reciprocal function, these two considered as asymptotes. X exists and Y exists become asymptote. Asymptotes meaning that the end here will not go to beyond that asymptotes, the ending point here. And also end here will not go exceeding these asymptotes. It's happened for reciprocal functions. And next,
horizontal stretch. Maybe.
okay, right, we go to one by one, horizontal. We go one by one. We didn't go to, where is it, horizontal stretch? This is number 3 already. We go one by one. Always I say that go one by one.
Horizontal shift to the left.
Horizontal shift. Is that we have horizontal shift?
Yes.
Yes, we have.
We do have horizontal shift. Shifting to the left or shifting to the right?
Shifting to the right.
Right.
Shifting to the right. How many units?
3.
3.
3 units. Therefore, okay, we write shift right 3 units. Okay. So, like that, we shift to the right. Shift to the right. Shift to the right. So, as it is here. So, point 1, 1 will go to which point?
4, 1.
4, 1. And point minus 1 will go to the points
minus 1, 3. My 3 minus 1.
3 minus 1.
2 negative 1.
2 minus 1. 2 minus 1 because shift 3 points. Start from the original is minus 1 and then 0, 1, 2. 2. Remember that X and Y exist. Now this is X and Y exist. This is just horizontal. This is asymptote just to show to you. But our asymptotes now move. Not X exists and Y exists any longer, right? X exists and Y exists there, but this is asymptote. Right. So what's the new function? What is the new function?
1 over x.
1 over x
minus 3.
minus 3. That's a new function. 1 over x minus 3. Then, what's next? What's next? What we go next?
Compress.
Nah, either we do reflections or we do compress stretch. Does not matter because can be interchanged. Let's say if we do reflection first. Reflect about what? X exists or Y exists? Or we say we do compression first, right? Doesn't matter. We do compression first. So compressions about vertical or horizontal.
Horizontal.
Horizontal. Is that compress or stretch?
Stretch.
Stretch. Why stretch? Why not compress?
Negative 2/3.
Huh?
Less than 1.
No. Not negative. Why negative? Now we're talking about no reflection. We're talking about compress first. It's located between 0 and 1. Not meaning that less than 1. It's located between 0 and 1. Right. You try to solve yourself. Then determine the domain and range. Tomorrow we don't have lessons. No lessons at 11 o'clock tomorrow. No lessons. So next lesson, I will see you back on Thursday morning, 8 o'clock. And remember that on that day, on Thursday night, you're going to have quiz number 1 for chapter 1. So remember, we don't have lessons tomorrow. Right. With that, I close the sessions today. Please try this with Tasbih Kifarah and Surah Al-Asr. Bismillah.
Thank you, sir.
Oh.
Thank you, sir.
Thank you, sir.